All right, guys. We'll be starting to discuss the scientific revolution today, and specifically, we're going to talk about many of the major figures, their impact, and stuff like that. So, here's what you're going to need to assist you with today. One, you'll need this article in artificial intelligence posted for you guys on Canvas or Google Classroom. And there's also a chart on all the major figures of the scientific revolution. You're going to need that in front of you so you can take the notes. That will help you with the work you're going to be doing and turning into us. In terms of the assignments, there's a discussion board that we want you to post in, and I'll explain what that means in a little bit. And then there's a scientific revolution wrap up, and you'll need the notes from the chart to do that effectively, and I'll explain exactly what that means when we get to it. All right, so let's just jump in. So again, we're talking about scientific revolution. Let's keep in mind we're going to begin this conversation on a bunch of different revolutions. So a revolution is a event that creates big change. So obviously, we're going to see a big change in the scientific community. It's going to change the way we think, the way we do things. Much of the modern world will be based off the things that are done during the scientific revolution. So it's kind of a big deal. All right, so here's the thing. Um, One of the things that we often do in modern times is we look back at the people who lived a long time ago and we tend to laugh at them, right? We look at them and go, how did you idiots believe those things? Why did you believe those things? You thought the earth was flat. Unfortunately, some people still think that now, but you thought the earth was flat. That's just silly. So here's the thing, right? Like sometimes we look back at them and we don't get it. But there's also other times when we look back at things that seem so painfully obvious now in terms of scientific advancement. And so, with that idea in mind, there's an article posted for you about artificial intelligence. If you don't know what that is, the article talks about it, but just real quick, it's this idea that there are computers that can begin to think and process information on their own, as opposed to us inputting the information. All right, and in the article, you will find two names that come up. The first name is Stephen Hawking, who's this gentleman here, right? One of the most brilliant scientists in the history of mankind. He suffered from a very challenging genetic disorder that basically left him in a wheelchair. So that's why he looks that way. And then Elon Musk, the owner of Tesla, the owner of SpaceX. He invented PayPal, billionaire extraordinaire, a little bit of a nut job. So anyway, read the article and then take some notes and identify what is the good and bad of artificial intelligence. All right. All right, go ahead and pause me once you go and do that, and then we'll come back together. All right, so here's what we want you to do on your discussion board, right? So here, if I put some pictures in here just to kind of help you kind of get an idea of this thought about artificial intelligence. People tend to think artificial intelligence will lead to things like Terminator. If you haven't seen any of the Terminator movies, you're really missing out. And let's be honest, you got time. Or more recently, something more like Ultron. He's an example of what would be considered artificial intelligence, a computer-based program or computer-based mind that can think for itself and make decisions. Here's what we're asking you to do in a discussion board. We want you to post. And in your post, we want you to identify two things the article said were good about artificial intelligence, two things they think the article identifies potentially being bad, and then explain to us, what do you think, right? Do you think artificial intelligence is good or bad? And again, what we're trying to help you realize by doing this is one, just to learn a little bit more about the world going around us, but more that we live in this world where we think we're so attached to science, that we are so advanced, that we just, we don't fight these things, but we see people fighting things like artificial intelligence or even like common sense when it comes to COVID-19. So this is just kind of like a way to get in the minds of the people who lived during this time period. All right, and oh yeah, your response should be at least 6 sentences. All right, so now that you've done that, on that chart with all the key figures on it, there's a couple key terms we want to go through or explain really quickly. First is the scientific revolution. You can write this textbook definition, or I can kind of simplify it for you. Here's what we want to think about, right? Um, Starting in the 1500s, people began to challenge traditional authorities. What does that mean? All right, what that means is a lot of people believed simply what the church said was true, right, without challenging it, or they took the ideas of ancient Greece, whatever they determined to be true about the world, and said that must be it. So what happens is those ideas, and the church took a lot from the Greeks too. Those ideas went kind of unchallenged for a couple thousand years. Well, suddenly people go, I don't know if that's really true. And so people begin to come up with theories of the natural world that begin to test those ideas. And we'll look at a couple of them in a second. A big part of this is the scientific method, right? You don't need to know all of this, right? But here's what you need to know about the scientific method. It is a process in which you begin to identify a problem, come up with a potential solution, and then test it, and then test it again, and then keep testing it and get data. And you have to keep testing it. So the reason you do that is because the only way you know something is 100% true is if every single time you do the experiment, you're getting the same result. And then if you do, that means you've learned whatever you're doing is proven because it keeps happening over and over again. This scientific method is a great way of studying the natural world, and that's what they did. With that being said, let's jump into the most famous people we want to know from the time period. So the first one is Ptolemy. That's this gentleman right here. The P is silent. Now, technically, all right, so I talked about from the time period. Ptolemy is actually an ancient Greek thinker. What we want to think about if Ptolemy is the key word that jumps out is he came up with the geocentric theory. Geo meaning like Earth. So he makes the argument that the Earth is the center of the solar system or the universe, whatever term it is. All right. And here's the thing, this idea gets immediately adapted by the Catholic Church. They love this idea. And the reason they love this idea is because, well, think about it. If you know anything about like Christian teachings, particularly the Catholic Church's teachings, they're going to make the argument that human beings are God's chosen creation. All right, that God made this place, God made it for us, we're made in his image, all that stuff, right? So it would make sense then we would be the center of everything if this all powerful, all knowing being made us, right? And to look like him or her. So the church goes with it and runs with it. Now, before you start saying, well, why would they believe that? Where's the science behind we're the center of things? Okay, here's a little experiment I want you to do. Stand up, take a book, any book, and then just quietly stand still and drop the book. What happens to the book? It goes straight down, right? So think about it. If the earth is moving and we're on it, when you drop the book, right, shouldn't it like not fall straight down where you are, but rather over a foot or this way or that way because the earth is moving as it's falling, right? So that logic got them to think, well, the earth can't be moving because when you drop something, it drops straight down. It doesn't fall to the left or right or something like that, right? Um, why is that the case? Because here's the thing, you, the book, the earth are all moving at the same speed. So therefore, even though we're moving, we're all moving at the same speed, therefore it's staying even and level. That's the scientific explanation from history teacher. I'm sure it's anyway, Bacon and Descartes. Big thing we want to know about these two guys. They're not scientists, they're philosophers, they're thinkers. They're the ones who begin to ask people to question and challenge things. So their argument becomes, again, they're two different people, but we're kind of combining them here. True knowledge can only be gained through experiments and reason. Simply accepting something as saying, well, God says so, or the church says so, unacceptable. The only reason we should accept something as being true is to do an experiment and keep experimenting until we get it. All right, doubt. You should doubt things, right? Don't blindly accept things. And that is the reason the scientific revolution takes place. People begin to doubt what was believed and challenge what was believed and try to disprove it. So legacy basically is like they didn't invent the scientific method or even research, but they begin to push people in that direction. All right. Next person is Copernicus. Now, Copernicus is one of my favorite people on the list, and here's why. All right. So he's an astronomer. That's a field of study. He comes up with the heliocentric theory, right? Which is that the sun is center of the solar system or solar system. All right. And then everything, including Earth, moves around it. How does he discover this? Well, he uses a telescope and begins to do charts and determines that it looks like everything's moving around us, right? Here's the thing. Here's why I like the guy. So he comes up with his findings. He writes them. He gives them to a good friend of his and says, listen, when I die, you can publish these. So basically, Copernicus knows what he's saying is just going to piss everybody off. So instead of dealing with the backlash of pissing off the church and powerful figures, he's like, oh, on the way out there, oh, here you go. Boom, mic drop. It's going to throw a grenade at you. Now, here's the thing with this, right? Because he's not around to kind of be attacked by the church or defend his ideas, the church can kind of sweep this under the rug and it doesn't really go anywhere, but it still does go to enough people. All right. That is kind of a big deal because here's the thing. Here's how science really works, right? You come up with a theory, you put it out there, and then it's other people's jobs to prove you wrong. So that gets us to the next guy, Galileo, probably the most famous person on this list. So he also is a focus on astronomy. He also proves the heliocentric theory, right? But here's the thing, right? He took Copernicus's idea and he went with it a little further. And here's where he gets himself in trouble, right? One, he doesn't die. Oops. The other thing he does is he's a devout Catholic. His daughter is a nun. Here's a guy who basically is trying to help the church. So he tries to take the heliocentric theory, right, the scientific theory, and he tries to basically combine it with Catholic teachings. Here's the problem. The Catholic Church doesn't want you to do that. They just want you to just accept whatever they say. And so his problem was not that he had these ideas, that he tried to reinterpret the Bible and try to make it work for them. The church doesn't want to do that. So what do they do to the guy? Well, they put him in a house arrest for the next 26 years. They make him publicly take back his theory and say he was wrong. Now, the crazy thing about this Galileo stuff is that the church didn't apologize to him until 1992. He'd been dead for hundreds of years. Not that it mattered to him at this point, but like that's the thing. The church was unwilling to bend, and they don't actually apologize until my lifetime. And I'm not that old. So this is Galileo reconfirming the heliocentric theory. But the thing that makes him different is that he tries to combine it with the church. All right, then we get to Kepler and Bra. Kepler and Bra, basically, again, astronomy. What they're going to do is they're going to take the heliocentric theory and say, yep, that's right, but it's off a little bit. So I just want you to look at the picture on your screen for a second. What you'll notice is if we were to go back real quickly to this picture, those are perfect circles. Instead, this is in more of like an oblong shape, right? So what he realizes, what they realize, they're two different people, literally at the same time. They go, oh, so the math you guys have been doing is wrong because they have these charts that say on this date this planet should be there, but it's not. What they begin to realize is that the reason it's not at this specific point in the sky is because it's traveling further, meaning it's not a perfect circle, it's this oblong shape. So this is a big breakthrough. Again, this is how science works. One person comes up with an idea and the next person challenges and tries to build on it. All right, the next gentleman we got to talk about is Isaac Newton. Isaac Newton, first of all, has delightful hair, like just great hair. He must condition your eyes and moisturize or something. It's just so nice. Big thing he comes up with is the law of gravity. You might have, as a little kid, heard of like Isaac Newton sitting under an apple tree and it falls on his head, and then he's like, oh, gravity. That didn't happen. All right, that's just a childhood like story way to tell people. Here's what he comes up with: gravity. Obviously, do you think of gravity as the thing, whatever goes up must come down thing? All right, it's a little more complicated than that. What he realizes is that gravity is what keeps us where we are. Gravity is what keeps the planets from flying off into space. The gravitational pull of the sun basically moves us and moves the planets around them. So gravity is what keeps us on the planet and also keeps the planets from like zooming off into space. All right. His ideas were then able to then explain why the heliocentric theory works. Again, you got to prove why we aren't moving. That's what he did. All right, the next thing he does is he invents calculus. What a joke, right? So this guy doesn't have math he can do the work he needs in physics. So he makes one up. Yeah, of course. Who wouldn't do that? So he basically invented calculus. Why is calculus kind of an important thing? It basically is the most advanced form of math. It allows you to do things like physics and chemistry. At least I think it does because I'm a history teacher. I have no idea. But the idea that he invented calculus, one, to help him do physics, and two, to torture you as you get later into high school. So you're welcome. All right, so here's what your assignment is. All right, on this scientific revolution key figures wrap up, you will see a series of quotes. None of them are real, but they are quotes that could have been said by somebody on your chart. What you need to do is step one, identify who that person is. So write the name. Then explain why that quote connects to that person. So what we want to see is that one, that you can identify who they are and that you can explain your reasoning and rationale. That you should look at your chart and look at their discoveries, the things they said, and all those things, right? So if you only give us the name, you're going to get like very little credit. You got to give both to get full credit. All right, guys, thanks so much. Hope you enjoyed it. We'll see you later.